Hello, welcome to Analog and Digital Communication System EC501. Myself, Dr. Indranath Sarkar, Associate Professor, Department of Electronics and Communication Engineering at JS College of Engineering. There are 5 course outcome statements. The first is to explain the importance of analog and digital modulation and demodulation schemes. The second is to analyze analog communication systems for their signal to noise ratio, efficiency, and bandwidth. The third is to compare the advantages of various pulse modulation techniques and analyze their system performances. The fourth one is to demonstrate signal representation, analyze various digital communication techniques, can compute the bit error performance and compare their advantages and limitations. So these are the listing of the 5 course outcome which a student should achieve at the end of the delivery of the course. There are a few prerequisites for this course, such as the Trigonometric Fourier series, Exponential Fourier series, Fourier transform and its properties, energy and power signal, probability and statistics. Now here is a simple example of a communication system. How it is useful today has been shown. At the top left, it is showing that it is raining and that will cause the flood. So this is an incident. So how our communication system helps us to get a relief from such natural calamity. Whenever this incident occurred, on the right hand side, we are seeing there are some sensors, satellites. These are useful to collect the data where the situation has been occurred, that is flood has been occurred, and through the sensors these are collected and they are communicated to the satellite so that it will be spreading to any part of the world. Now as we have the computer and internet system, the expectation simulation system collects all this data from the satellite. They are spreading this information to the internet where it is connected to computers, televisions, transistors, newspapers, mobile phones, laptops, etc. The data collected by the crisis staff as well, they are involved in several types of meeting where it has been decided how to get relief. So action plan has been prepared which has been sent to the intervention staffs who are involved to employ how many ambulances, what are the food items, as well as what are the machineries required to rescue people, as well as any assets which are getting damaged due to flood. Now this is an example of a basic communication system, that is what actually tells us about the electronic communication system. A simple example shows the mouth is producing the acoustic vibration which is incident on the transducer called microphone. The microphone produces the electrical signal that has been processed by several processors to produce the current and voltage type of electrical quantity which are incident on transmitter to produce the modulated signal. That means the message has been converted into electrical signal which is a carrier type of signal which has no information, but it could be a bearer. So that bearer electromagnetic wave reaches the receiver which extracts the information from the bearer signal so that it will be fed to the transducer called loudspeaker which is producing some acoustic vibration which is reaching to our ear so that we can identify what information has been sent by this communication system. Now here we are seeing some connectivity At the top, it is showing that digital information is given input to the system, which is connected through the modem to the internet, where the transmission line bears the analog type of signal from one end to other end. On the other end, there is also another person sitting on the computer through modulator demodulator system. He is getting the information on his computer. At the bottom, it is showing that there are some analog devices are also connected to the network. The network is of digital type. That is why there is a conversion required for analog to digital through IP gateway. So it is transferring the data into the internet through wide area network or local area network, and thereafter the digital data is collected by the IP gateway, which is transferred to the analog phones. Now here a basic definition for the analog and digital signal are showing, as well as the comparison is also showing. On the left hand side, it is a pure analog signal. What is analog signal? Analog signal is shown in terms of sinusoid. It defines that with respect to time, the magnitude is varying continuously. There is infinite set of magnitude with respect to time within a finite limit. So this is analog signal. On the right hand side, the red line is the analog signal, but the blue line is the approximated digital signal. So therefore, the basic definition of the digital signal comes out from this figure is that the blue lines are the fixed magnitude which are showing almost approximation of the related analog magnitude at that particular instant of time. So these steps are further required to be coded with binary 1 0, where 1 represents the high voltage and 0 represents the low voltage. This high doesn't mean that very high, but it is around 5 volt, and 0 stands for 0 volt. Now there are other definitions of this logic 1 and logic 0 depending on the system, whether the 1 may be represented by not 5 volt, but it is a range between 2.5 to 5 volt. 0 may be represented by 0 volt to 0.8 volt. So system to system it depends, but still 1 and 0 represents a very low voltage. Some analog communication devices are shown. The headphones we regularly use are also processing analog signal. The speakers, which are giving us loud sound, are also analog devices. The thermometer, the microphone, these are all analog devices. In the earlier days, we know telegram was sent by a small device which is shown on the left hand side at the bottom. At the middle, this telegram device is also analog system. On the right hand side, there is a ancient phone, which is a dial phone, is also analog system. At the bottom, some old phones as well as computers are shown, which are also having the analog signal to be processed. Now, at the initial stage of the communication, digital communication, we have seen that there are some digital phones as shown on the left hand side. Similarly, on the right hand side, there are some old digital mobile phones in which the antenna is coming out of the device. There are some prerequisite for this analog and digital communication system. First of all, we need the basic idea of the trigonometric series. So before going to this course, we should have a recapitulation of trigonometric Fourier series. Now, what does it tell? We know there are several types of practical signals, such as it may be a square wave, it may be a sawtooth, it may be a triangular wave, it may be a semicircular wave. But see, there are all these signals are not the pure signals, but it is the nature of the signal that has been extracted by a system. So it is a superposition of other signal, but since it is square, since it is sawtooth, since it is triangular, since it is semicircle, so whatever is the type of the signal, we need to represent it mathematically so that we can process the signal through our devices. because our devices knows mathematical operations. The basic idea of Fourier series is to represent any periodic function with simple sine and cosine waves if m and n are any two different integers, then the function set 1 sin mx cos nx is an orthogonal set of functions on minus pi to plus pi. In Fourier theory, we can establish such a set of sinusoids of different frequency as an orthogonal basis for continuous signal in frequency domain. The trigonometric Fourier series is continued with a simple form, that is ft is given by a0 plus summation of the remaining cosine and sinusoidal terms, which could be simplified to a smaller expression as shown on the left hand side corner. It can be represented using the complex Fourier series on the right hand side. It is showing that we can replace the cosine and sinusoidal function with the exponential relation, and thereafter we can reduce the function to a very small expression. The prerequisites of the Fourier transform is also very much important, because Fourier transform gives us the knowledge about transforming the time domain signal into frequency domain spectrum, and the frequency domain spectrum is important for analysis of analog and digital signals, as there are various tuned circuits which are processing this type of signal. So that is why Fourier transform is essential. It is showing that how the Fourier transform uh, can be found from the Fourier series expression. At the top, Fourier series expression is given. If we take the Fourier transform, it is showing that the Fourier transform of a periodic function consists of a train of equally spaced impulses. These impulses are located at the harmonic frequencies of the signal, and the strength or area of each impulse is given by 2 pi into Cn. These are the important properties of Fourier transform, which shows that the linearity property, which is the superposition property also, as well. That is, if xt and x omega are Fourier transform pair, as well as yt and y omega are also another Fourier transform pair, then the Fourier transform of the weighted sum of time domain signal is equal to the weighted sum of spectrum. That means xt has a spectrum x omega, yt has a spectrum y omega. So if you take the Fourier transform on the left hand side, you will not get any difference in the scales of the constant values, but the corresponding spectrum you will get. The time shifting property shows that if xt and x omega are the Fourier transform pair, then the Fourier transform of the time delayed signal is the product of the spectrum and e to the power minus j omega t0. Similarly, the frequency shifting property states that the Fourier transform of the product of the time domain signal and e to the power j omega 0 t tells us the shifted spectrum in the frequency domain. The time reversal property shows that if time is reversed in the time domain signal, then the Fourier transform of the same is given by the spectrum with time reversed. The time scaling property shows that if we take the Fourier transform of a time domain signal where time is scaled with a certain factor, then it is showing that 1 by a x of omega by a will be the corresponding spectrum. The differentiation and integration properties are also shown here. There is also multiplication and convolution properties. So these are the important properties we should revise before going into the analog and digital communication system. The very basic requirement of this course is to know what is an energy signal and power signal. Normally, power signals are having infinite energy, but energy signal should have zero average power. So this is the basic statement to differentiate the energy and power signal. Normally, energy signal states that a signal should have finite energy. So therefore, the equation of energy can be verified with example as given xt is equal to e to the power minus t into ut. Ut is the unit step function which is valid for t greater than 0. So if we take the energy of this signal, it is showing that it is 0.5, a finite value we are getting as a derived energy of this signal. So therefore, it is a energy signal. Similarly, power signal, that means first of all we have to calculate the average power of that signal. If the average power shows finite value, then the signal is a power signal. So with an example, it has been shown that the power signal has finite energy, finite power, average power. The concept of probability is also very much important to know the digital communication as well as noise calculation in analog communication. There are many incidents which are occurring in our surroundings, such as tossing a coin. Tossing a coin should have two number of outcome, either head or tail. Both are of equal probability, that is why both are having probability half. So it is showing that h and t represents heads and tail are having the probability half. Now what is probability? It means the ratio of the number of favorable event to the total number of outcomes. One example is showing that suppose you are looking for the number 4 when you are throwing a die. So it is the single case out of the 6 cases. Therefore, the number of favorable event is 1, whereas there are 6 such possible events for every throw of die may occur. So that is why the probability of throwing a 4 is 1 by 6. The conditional probability is a very important tool to find out the dependency of two such events. Suppose there are two events A and B, then therefore the conditional probability of A with respect to B is the quotient of the intersection of the two probability to the probability of B. In the statistics, the joint probability is an important factor. If two events are independent, statistically independent, if the occurrence of one does not affect the probability of occurrence of the other. Two events A and B are independent if their joint probability equals the product of their probability, that is P of A intersection B is equal to PA into PB. Random variable is another statistical tool which is important for digital communication, where it is telling that every outcome of a random experiment should be numbered. So random variable can be derived from an equation. Suppose there is a heads and tails for tossing a coin. There are two outcomes. So often we want to represent outcomes in terms of number. So random variable is a function that associates a unique numerical value with every outcome of an experiment. The value of the random variable will vary from trial to trial as the experiment is repeated. A discrete random variable is one which may take only a countable number of distinct values such as 0, 1, 2, 3, 4, etc. So discrete random variables are nothing but numerical numbers which are associated to every outcome of a random experiment, but finite in nature, whereas in case of continuous random variable we are seeing that infinite number of possible values may be occurring. Continuous random variables are usually measurements such as it includes height, weight, the amount of sugar in an orange, the time required to run a mile, etc. So therefore, this is all about the introduction to analog and digital communication system. In the next video, we will enter into the introduction part of the analog and digital communication system, in which we will discuss first the need for modulation as well as several analog modulation systems, and there are some recapitulation of the signals and systems.